This conference will now be recorded.
Are you able to see my screen? Ashok, Rajesh, anyone can confirm?
Yeah, Chandra. Can I able to you?
Okay. Yeah. So we'll get started. So this is basically on the networking part of our AWS, which is very important. And so we're going to talk about another service called important service, a virtual network service called virtual private cloud, which is VPC, right? So by end of this session, you would have done completely this one. Okay. So I'll guide you step by step to go through this. And this is what you will be doing and you will have done at the end of this particular VPC session, right? So before we actually jump into networking, let's rewind back to our memories to our college days, right? So we'll have to refresh our some of the basic networking things that we have. Then we will come back here and see what we have from AWS, right? So let's do that. So I'm not a networking guy, but just for this one, I just know a few things on that, right? So if anybody is on the network pro or geek guy, please correct me if I am wrong somewhere. Okay. So normally there are three types of networks that we have in our networking world. One is class A, class B, and class C, right? I think you would have heard of this. So class A network, class B network, and class C network. And if you see, let's take one IPv4 address, which is a 32-bit address, say 10.0.0.0, right? Let's take this 0.1. Okay, let's take this address. Now, what is how can this be classified as a class A, class B, and class C? Okay, in class A, the first digit remains the same. Okay, so the second from the second bit it can change from like this. Okay, 0 to 255 dot 0 to 255. Okay, all these three can change. This is a class A network. It's a very big network. Okay, we will talk about ranges and stuff, but this is a very big network. So when we do like this, it's a class A network. So the first bit from the left always stays the same, and second, third, and fourth changes from 0 to 255. So totally it is 256. So 0 to 255. This is your class A. So how will your class B be? Anyone can guess what your class B will be? So the class B will be, the first two will remain same and the last two will change. Okay. And this is a medium. This is a medium and the normal one that we keep using in all our companies and everything, right? So this kind of a medium network. And this is a smallest network that we have, where you have all the three, only the last one will change. This is your class C network, where we have in our home and all, right? We have in our home. So if you go to a laptop and check, it will be in our home network. So home network will always have a maximum 256 IP. That is the smallest network. So these are the three types of networks we have: class A, class B, and class C network. Okay. You need to know something called CIDR. Okay. CIDR is nothing but classless inter-domain routing. Okay, this CIDR, classless inter-domain routing. So we don't worry about much about the class, but still AWS uses this class B network. Okay, we all use in our organization also this class B network. This is a huge network. This is a huge network. So when we say this, right? So when we say it's a huge network, how is that? So each and every number in this represents 8 bits, right? So total it is 32 bit. So if you have seen any network range or something, they would have put it like this: 4/16/24, right? So this is how you represent a network. So in class A, what will happen? You have 8 plus 8 plus 8. So what happens? All the three got this one, right? So you are left with only 8 bits now. So this particular network will always be a /8 network, the bigger one. Okay. So here it will be a 16 network. In class B will be a /16 network, and this guy will be a /24 network. So these are all 8 bits, right? 8, 8, 8, 8, 8, 8. So only the first 8 is there. So /8. The first 2 bits are not changing, /16, and this one is /24. Okay. So how do we calculate the number of hosts that we will get, number of IPs that we will get, right? Let's assume, for an example, let's take this. Just stop me if you don't understand anything. Okay. Let's take this 10.0.0.0 and say it's a /8 network. So how many IPs or how many hosts that I can connect, right? How to calculate this? You have to do 32 minus the subnet, whatever we have here, the 8-bit. 32 minus this one is 22. Then the number of IPs that you will get is 2 to the power 22. Whatever number comes there for 2 to the power 22 is the number of IPs that you will get if you use this class A network. When you use the class B network, similarly it will be 32 minus 16. So that is your 16 and 2 to the power 16. Don't worry too much about this. Okay, there are sites which can help you, but you need to understand why the trainer or wherever you go that you are able to see this, right? So 2 to the power 16 is basically 65,536. Okay, 536 IPs you will get in a class B network. So that's a huge network. Okay, when you come to home network, right? Home network usually is 256 because it is 2 to the power, it should be 2 to the power 8. So 32 minus 24 is your 8. And if you do, then it's 2 to the power 8, which is 256, right? So these are the number of the lowest IP that you can get in /8/24 network at this one. So what about AWS, right? AWS uses class B network. AWS uses class B network, and the subnet range that AWS uses is maximum is /16 and minimum is /28. So only within this, the AWS works within this range only. From 65,000 to 536 to 2 to the power 4, it's 16 IPs. So maximum IP we can get is 65,536 or 35. That will be the max, and minimum will be your 2 to the power 4, which is 16 IPs. So this is what the range in your AWS is, right? So this is maximum that you can have /16 and minimum is /20. Don't interchange, because by seeing the larger number there, okay, the smaller the one, the higher the network. So /16 is maximum and /28 is minimum. Okay, suppose you have only 2 machines, then you can go for /28. Okay, there is some catch to this also, right? Suppose you are having 10 systems, right? 10 or 11 systems or 15 systems you are having, you cannot use /28 because AWS reserves some 5 IPs for some internal use. We will see what are those things. So whatever number of IPs you get, -5 is the one that you will get the final one, which is available for you. Okay, so you need to choose correctly. Okay, any questions here, guys? Any questions here? Please let me know. So these are all IPv4 address. Okay, these are all IPv4 address, and they are 32 bit. 32 bit. Okay, so these are all class A, class B, class C, and there is a classless also, right? There is a classless where all the IPs can change, right? All your IPs can change. This is nothing but your internet. This is nothing but your internet, because internet has all the IPs. So it is represented as 0.0.0/0/0 that you will have. Then what you will have, this number of IPs, right? 2 to the power 32. 2 to the power 32. 32 minus 0 is 32. So 2 to the power 32, whatever number comes there, 4 million or something, that's what you will get for internet. So other than this network, all these things will represent internet. Any questions here, guys? Get it clarified, because we will be using these terms then and there, and you should not get yourself confused what we are talking about, right? So we are using IPv4 address now, and IPv4 address 2 to the power 32, 2 to the power 32, which is nothing but your 47 million or 4 something, right? Something is coming. Go and check in the Google for 2 to the power 32. That is the number. And so we are running short of IPs in the world. Okay, why we are running short of IPs in the world? When these IPs were all formed like 25 years ago, right? 25 to 30 years ago, they thought that 4 million or 47 million, 4.7 million IPs were sufficient for the world to use, because the number of devices that we had at that point of time. Now what is happening in my house? Let us take my house. I have 2 laptops, one office, one my personal laptop. I have a mobile, my wife might have a mobile. Then we have some device, that TV which connects to some network, right? So I myself in my home, we have around 5 to 6 or maybe 8 average 8 device that needs an IP. So any device can talk to another device only through IP, only through IP. So what was happening is the world was running short of IPv4. So then there came a small relief for us. I think you would have heard of this one. That's called NAT, right? NAT. This is nothing but your network address translation. Network address translation. Let's see how this is trying to solve our issue. So what happens in my house, right? Let us take our own house, right? So I have one router from Airtel, and there's a connection going to the wherever that hub is. I have only one IP. I have only one public IP for my house, correct? So I have only one public IP, but each and every device I have in my house has a private IP, has a private IP. Now, what I do, I just put my LAN card or Wi-Fi. What happens? I try to Google from my system. What will happen? And my wife tries to do a yahoo.com. So how does one IP is sufficient for all, right? That's where your network address translation happens. So what will happen? Both the requests from my laptop for Google and from my wife's device for Yahoo, both will go to the router. Both will go to the router. While it is going, the request will go along with the private IP of that device. Okay, it will go to the router. Now your router will behave as a NAT, network address translation. Now what it will do, it will hold your private IP, and then the public IP, whatever is there, it will take the request and go outside the internet, connect to your Google, come back to the router, and router now knows from where this particular Google request came in. So it will attach that private IP and send it to my device. For Yahoo, it will send to her device, right? So this is what we do, a network address translation. So what is the advantage here? I don't have to have, if I have a 6 device, I don't want to have 6 public address. I need only one address, and I need a NATing device. So all our routers now act as both routers and NAT. Okay, so this is a temporary fix. This is just a temporary fix for the problem. This is not the actual solution. They came up with a solution called IPv6. I think you would have heard of this. IPv6, which is a 56-bit. So 2 to the power of 56 is going in billions and trillions, right? So this will at least solve the problem for the next, say, 5 to maybe 8 to 10 years. We don't know, right? 8 to 10 years. This can solve the problem. That's what the network people are thinking, and they have come up with this IPv6. Now, okay, now can we use our IPv6? No, IPv6 is available, but again, remember, all IPv6 addresses are public addresses. There is no private range for IPv6. That is why still we haven't switched to IPv6 in our companies, right? We are still using IPv4. But the problem is, all the devices that we have right now in the world are only manufactured to talk to IPv4 or accept IPv4 compatible. So we need to have new devices. Now even the AWS, all the EC2 machines are IPv6 compatible. Whether you're using IPv6 or not, it is IPv6 compatible. So all the machines all the devices need to accept IPv6. Then we need to change. It will take at least 6 to 8 years. And even today, at least in India, right? Even though we talk about 4G, 5G, only now certain villages have got 3G itself, right? So it's going to take time, but you need to know that this is something that is coming up. Okay, so this is some of the key terms. Just keep in mind, and how do we calculate all these things, right? So any questions here, guys? I'll just stop here. Have any questions? And as we know, in the IPv4, we have two types of IPs. One is public IP and private IP, right? Public IP, we'll talk about public IP. Private IP, there are three IP ranges that are defined as private as per the internet standards. So what will happen? Those IPs will never be routed through internet. So those IPs are, that starts with 10 dot, okay, then 172 dot and 198. 198, right? Quickly check 192 or 198.
192.
192. Okay.
Yeah.
Yeah, it's 192. See here, 192 is our private. So anything that starts with 192. So these three ranges are called private address. So they are used only for private LAN purposes, right? So all our home network falls under 192, and this guy AWS by default uses 172, but we can go and change whatever we want. So these are all the three private IPs. Other than this, all the IPs in the world are public IPs. All the IPs that are like this, right? They are all public IPs, which are internet routable public IPs. Okay, you need to keep that in mind. So when you see 10, 172, 192, you cannot do. So suppose if you don't connect to your wireless, or if you don't plug in your LAN card from your router and try to do Google, it will not go because it has a private address. It doesn't know what to do. It doesn't know where to go, right? But if you plug in your LAN card, what will happen? That traffic will go through that and go to your router, and router will do a NAT. It will send you outside, come back and give you, right? So that's what it's going to do. That's where your NATing is there. Since that NATing, they found out this NATing, and we are able to now manage with the existing IPv4 address that we have. Okay, and this is going to sometimes it's going to drain off, and we are going to run out of IPv4 address. So IPv4 address is always represented as 0.0.0/032 bit. And how about this one? This one is done like this. Okay, the IPv6 is done ::/0 is wherever you see this number ::/0, then it is a IPv6 address. Okay, that means all IPs under IPv6. On the top, it is all address under IPv4. Okay, so this is how representation. So when you go to the exam or sit for the interview, right? See, we don't know, right? Again, it all depends on the interviewer, right? So if you are going for a network kind of this one in AWS, right, then probably you might come across all these questions there, right? And how this works and how many IPs, how do you calculate the CIDR ranges, classless inter-domain routing, that is called CIDR ranges and all those things, right? So we will stop here. I think it's too much. So we will stop here. Just keep in mind, we have different classes of IPs, and we will be using classless inter-domain routing for our this one. And what is the maximum and minimum? That's what you need to understand. 16 and 28. 16 is maximum and 28 is minimum in our AWS. Okay. With this background, let's get into this VPC. Let's see what is VPC and what are its components and how do we kind of create our own VPC. So far that whatever that we have created our EC2, we never touched anything on the network. So default it connected to the default network, and default it was connected to the internet. Now when we are going to create our own custom, from now on we will be creating only our own custom VPC. So we will create our custom networking. We will put all the solutions there, and we will try to connect to the internet, and we will do all sorts of things. So this is what some of the features of VPC, and we will see all these things, and you would have done this by end of this session. Okay, we'll go back and validate this at the end of our session. Okay, as we complete one by one, we will go and see this. So VPC lets you provision a logically isolated section of your AWS cloud where you can launch your AWS resources in virtual network that you define, right? We can define our own network and you can go and do. So how can we compare this to an analogy, right? Say, for example, you have a street, right? Outside your apartment, there is a street. That's a public AWS. Okay, everybody can come, everybody can go. But the apartment is private to you. It is your VPC. It is logically isolated from your public. No one can enter unless you give explicit permission to somebody to enter into your apartment. So that is, just think of your private apartment as your VPC within your public AWS space or the street, right? That's where you need to think about that. It provides complete control over virtual networking environment, including you can select your own IP ranges. Again, these are all private IP ranges, not public. Okay. Creation of subnets. You can create subnets. You can configure route tables, gateways, and routers, and so many things. So we will kind of see this as we go and try to put some apartment analogy so you don't forget this when you sit for your exams or for interview. A VPC is logically isolated from other VPCs. So it is like having two apartments closely, but both are private and both are private to each other, right? Both are isolated. You don't have any connection between both unless you come outside the road and go to the next building, right? You don't have any connection. So they are logically isolated. So using VPC, you can connect your corporate data center to a VPC using site-to-site connectivity, VPN connection. That's what we are doing now. For all your work from home that we are doing, we log into a VPN connection, and a site-to-site tunnel is being established between your office network and your home, your VPN, and then you are able to log into your office network and stuff, right? So similarly, you can connect to a VPC using site-to-site hardware VPN from your company, right? You can do that also. Very important, VPCs are region-wide. They are regional scope. It cannot go outside the region. So if you create a VPC in Northern Virginia, it can only reside within Northern Virginia. That is why when you create an EC2 inside that VPC, that EC2 is visible only inside Northern Virginia. If you go to Mumbai, you cannot see them because they're all region scoped, right? They're all region scoped. Next, whenever you create an account in AWS, a default VPC is created for each region with a subnet in each availability zone. So suppose if you have created an account in US East 1, there are 6 availability zones there. So 1:1, they have a 6 subnets. Okay, we will talk about what is subnet and how to do a subnetting in that, right? By default, you can create up to 5 VPCs per region. This is a soft limit. You can create up to 5 VPCs per region. If you want to create more than that in the free tier, you need to raise a request to AWS support and provide your business case. And once they are convinced of your business case, then they will enable an additional VPC for your region. But at least the one that we are all learning now, it's more than sufficient. 5 is more than sufficient. We will never even reach 5. A default VPC is automatically created in each AWS account the first time AWS resources are provisioned. So when you create an account, by default, there will be a default VPC, and the default VPC will have number of subnets is equal to number of availability zones. If you are creating in Mumbai, you will have 3. If you are creating in US East 1, you will have 6. And all the subnets are public subnets. That means you can connect to internet. That is why when we created EC2, we were able to connect SSH, we were able to do all those things, we were able to do everything, we were able to ping Google, everything we are able to do because it is all public subnet. But when we define our own subnet, we are going to make something private, we are going to do something public, and how to do all those things, that's what we are going to see. Okay. Please stop me if you have any queries, okay? Please get it clarified, okay? It's very, very important. Again, just for your information, in your organization in real time, nobody will be using the default VPC, okay? Everything will be custom VPC. We have to create our own VPC. So if you go back to your office and check for default VPC, it will not be there. But when you create an account, it will be there, but you can delete it also. Earlier, they did not allow to delete before 5 or 6 years. Now they are allowing us to delete, okay? So that will not be there. So just keep that in mind because they are all public. Some of the components of VPC, let's talk about some of the components. Don't worry about all these things. Just know the names, then we will go back and see one by one. So the components itself is a VPC is one of the component, a logically isolated virtual network. You can define VPC's IP address space from ranges that you select. If I want a range from 10.0.0.1 or 10.1. something, I can go and put my own thing. So subnet is nothing but a segment of your VPC's IP address range where you can place group of isolated resources. So normally they map like one availability zones to one subnet. So it is like this, right? Say for example, you are buying a land, right, for 1,000 square feet, right? That's a VPC, 1,000 square feet. Now you are free to create how many houses you want, whether you want to create 10 houses with 100 square feet or you can want to create 5 houses with 200 square feet. It's up to you. So those type of houses that you build are called subnets, right? You are kind of breaking the bigger network into smaller things for you to place different resources. That's called your subnetting, right? You can subnet, but you can all do that within that range only, within the 1,000 square feet. You cannot go beyond the 1,000 square feet, right? So we have to plan while we are creating our house inside the land that we are buying. We will always have a future in mind and keep some space always for something, right? Similarly, when we are creating a subnet in a VPC, we always need to plan ahead because we don't know what is going to come next year, right? So when something comes up and you're running out of IP and you've already segmented fully, then again you need to create a new VPC just for that. So it's always better to don't when you're designing this, it should be futuristic, right? Even though you don't do like 10-15 subnets ahead, but at least 2 or 3 should be there for future use. So there is something called internet gateway. Internet gateway is an Amazon VPC site connection to the public internet, right? So this is internet gateway is a component which you need to create and attach to VPC so that you will be able to connect to outside world. So it is like your main gate in your apartment, right? Only through the main gate you can go outside to the public and come back, right? So that is your internet gateway. Next we have NAT gateway, just like what we talked about NAT, highly available managed network address translation service for your resources in private subnet to access the internet. So if you are in a private subnet or if your system is in private, how you want your system to access your internet, it is through NAT gateway. Just like our house, it is I have a private IP and this laptop is private to me only. Nobody can access my laptop. Even if you know my IP 192.168 something, you cannot access my laptop. Okay, because I'm in the private one. So I will go to the internet only through NAT. So that is why nobody can SSH into your system, into my laptop now, even though I give you the public IP. The reason for that is a NAT and it gets stopped in a router itself. So it doesn't, that outside traffic will not come inside and come to your system. They hack you, right? They cannot do that. Okay, that's because of your NATing. Then we have hardware VPN connection. That's a hardware-based VPN connection between Amazon VPC and your data center, home network, or co-location facility, right? It's a VPN connection, just like your site-to-site VPN that we have, right? So using a VPN client, you can connect to your VPC from your home or your office. So virtual private gateway. This is the Amazon VPC side of VPN connection. To create a VPN connection, you have two sides. One is on the customer gateway, one is on the virtual private gateway. VPG is on the VPC side, customer gateway is on the customer side. So that customer gateway is a device, right? Some device you need to configure and provide the IP. This virtual private gateway is a virtual logical device that you need to kind of configure on the AWS side. Then you have routers. Routers interconnect subnets and direct all traffic between internet gateways, virtual private gateways, NAT gateways, and all the subnets, right? Without the router, the traffic will not go. So it is like there is a delivery boy from Swiggy coming into your apartment. He is entering through internet gateway, that is your main gate. He has come inside from outside to inside, he has came. Then what he will do? Next, he will look at the table or the name board that is there in front, right? It says A1 Chandra, A2 Suresh, A3 Ganesh, right? They have that. They will put all those, that's called your route table. So using that routing table, he will know, okay, in first floor, this guy is there and he will go there and deliver the food. So that is how the networking also happens. We need to have a router. We need to have a router, and that router will actually help to route the traffic accordingly based upon where it is coming, where it needs to go. But you need to write the route entries inside that router. We have a routing table and we have routes inside the routing table. You will see all these things, don't worry. Then we have something called peering connection. A peering connection enables you to route traffic via public private IP addresses between two peer VPC. Now, I told you we have two apartments, apartment A, apartment B, next to each other, and they're all private. But unless you mutually agree, you both agree, and everybody is fine, you can set up an internal gate to go to the next apartment and come back, right? That is called VPC peering, going to that apartment without going to the public space, without going outside of our main gate. We just create a gate or a connection between two apartments. That's called peering connection. You can peer two VPCs. You can peer two VPCs provided there is a condition that two VPCs should have different IP ranges. Okay, they cannot have the same IP range. Suppose one VPC is having 10.0.0.0/16. Other one also cannot have 10.0.0.0/16. It cannot have. Okay, if it's like that, you cannot peer, because again the routing table, you cannot have duplicate entry, and if you have the duplicate entry, the traffic will not know where to go. So there should be no overlapping CIDR blocks when you are trying to peer the connection. So this is just like having our private gate between two apartments after the mutual agreement between both the owners, right? And you know, only those people those who reside in those both apartments can go in and come to those apartments privately, but not the people from outside. Okay. And one more thing is, like, there are a couple of we have seen a lot of services like S3 and other services where they're all global services. IAM, Route 53, DynamoDB, they're all global services. When we talk about global services, they have a public endpoint, so you can access it through internet, right? So VPC endpoints and you can create some VPC endpoints where you can talk to all the services in a privately without going to any gateway or any proxies, any firewall. Internally, you can talk privately using VPC endpoints. So we will create VPC endpoints and we will try to access our buckets and see if we are able to access, and how we are able to access without the endpoints through internet, through VPC endpoints. We will see all those things. Then, as I told you, internet gateway, right? Internet gateway is mainly used only for IPv4 address, whereas this address only internet gateway is used for IPv6 traffic only. A stateful gateway to provide egress only access for IPv6 traffic from VPC to the internet. So egress only means what? What is egress? Egress means outbound only. Egress means outbound. Ingress means inbound. Okay, keep this term because this will also be coming in your security groups, like inbound and outbound, egress and ingress. Okay, egress only means only traffic can go out. You cannot log in using this IPv6 from outside. Okay, so that is the point here. Okay, any questions here, guys? Just know these terms and we will just go through. So we talked about CIDR blocks, right? So class plus inter-domain routing. CIDRs are used for security group rules or for networking in general, right? All this one. They help you to define the IP address range. So whenever you see any IP as /32, that means it is a single IP. Why it is single IP? 32 minus 32 is 0. 2 to the power 0 is 1. So it represents a single IP. So whenever you represent in network world any single IP, then it should be your /32 should be your single IP. Say for example, now if my public IP is 11.22.33.44, if you want to represent in the networking one, it should be /32. You cannot simply say 11.22.33.44. It will not work. Okay. The reason for that is 32 minus 32 is 0. 2 to the power 0 is always 1, so it always represents single IP. /32 is always a single IP. And we have seen that all 0.0.0/0 is equal to all IPs, all the IPs, right? So we can define, for example, you can define all these IPs like this is /26 means, again, you 32 minus 26, right? Whatever number you have, 2 to the power 6. So 2 to the power 6, you have 64 IPs. So it starts from 192.168, 168.0.02, 192.168.0.63. It's a class C network. It's a class C network C. Only the last one changes from 0 to 63, depending upon this number /26, right? So any CIDR will have two components, right? Any CIDRs will have two components. The base IP 11.22.33.44/26 is the subnet mask. It's a subnet mask. The base IP represents IP contained in that range. Yes, it is in this range. The subnet mask defines how many bits can change in the IP, right? It depends on that only. /26 means how many bits can change. How many bits can change. The subnet mask, you can either say 255.255.255.0, which means less common to use. We always say /24, /26, /16. So like that we include, it's a more common way to represent your CIDR block. Okay. So the subnet mask basically allows a part of the underlying IP to get additional next values from these IPs. So /32 is a 1 IP, 31 is 2 IP, 30 is 4 IP. So like that, if you do the math, it is /16 is 65,536 IPs you have. Okay, so you have, and your AWS allows from 16 to 28. Okay, from 16 IPs is the minimum, 65,536 IPs are the maximum, and 0 means all IPs, 2 to the power 32. So /32 means no IP number can change, it's a single IP. Whatever IP you are giving /32 is the same. /24, last IP can change because it's a class B. /16 is last 2 IPs can change, that is your class B. /8 is your class A, which all the 3 numbers can change. And /0 means all the numbers can change in the bit. It's a internet IP. All the other IPs in the internet can change. Okay, this is just for your quick this one, right? So /24 will have, we know how to calculate this, 2 to the power 8. 2 to the power 8 is 256. So it always starts with 0 to 55. Add this 0 to 255, it is 256 IPs. Okay, so /16 will be like this, right? See, 0 to 255, 0 to 255. If you count all these things, it will be 65,536 IPs you will get if you're doing a /16. So /32 is just a single IP. This is some example, right? Single IP, and this represents all IP. So I have given you some sites where you can go and see all these things. You need not memorize this, but you need to understand the concept behind this, right? So we talked about public and private IPv4 address. So the Internet Assigned Numbers Authority, IANA, right, established certain blocks of IPv4 for the use of private LAN and public internet address. Private IP can only allow certain values like 10, 172, and 192, right? So these are all the private IPs. All the rest of the IPs on the internet are public IP. Okay, so even if this is 198, 191, 193, all are public. Okay, anything that starts with 192, 172, and 10 are only private. Okay, so this is what we call /8 in class A. This is your default. AWS uses this particular range in 172, 31, 16 to 31. This is what these guys use. So they is reserved for AWS. When you are creating, you don't have to overlap with this. And 192, 168 is, of course, it's our home network. Okay. Okay. Any questions before we get into this one? Okay. I try to keep it very simple, just for you to understand what you need to know for this course and for your interview or your exam. That's all, not more than that. If you are really interested to learn more, please go to Google and search for all these things. You will see tons and tons of materials. And if you are having interest in networking, you can go through that. And if some of you are anybody in the networking background, just for your information, you also have a certificate for network specialty where you will talk about so many protocols like BGPs and all these other networking terms in AWS. Okay, so default VPC walkthrough. Let's go and see what are the default VPCs we have. So all new accounts have a default VPC. New instances are launched in default VPC if no subnet is specified. So what we do when we create an EC2, we don't do anything. We simply go and select our AMI and put our security group and launch a machine. We are able to launch. We are able to log in. That's because we are under default VPC, and all the subnets inside the default VPC are public. Default VPC have internet connectivity, and all our instances have public IP, right? So we also get a public and private DNS name for your default VPC. So if you log into your AWS, let's go and see what we have for our default VPC. Go to VPC, search for VPC, or you can go to services networking. You can say VPC, or if you have already visited, it will be there in the recently visited stuff, right? So click on this one, and you'll get to this dashboard. You'll get to this dashboard. Click on the VPCs, right? This is the default VPC. Now the name, I've given this name. Okay, they did not give the name. Then for you it will be empty, and there will be an ID. You will see you will have 17-digit ID. I have only 10-digit ID. The reason is this was created like at least 6 years back, right? 4 to 6 years back. That was the time it was only 10-digit, and now it is 17-digit. Okay. See here, the CIDR range that they use by default is 172.31 network, right? That's what we saw. 172.31/16 is where these guys will. It's reserved for this one. See, 172.31 is where these guys are using now, right? /16 is what they're using. So this is a default VPC. This is a default VPC, and everything is default for you. So you are able to kind of see this is the CIDR block that they have. That is why whenever you create any EC2 machine, right? Use EC2 machine, then you will get a private IP starting with 172. Let's go and see what is the private address for any EC2 if I already have, right? I might have put it in the default because I don't have any other VPC. So now let's go to that EC2. Now you'll know the difference, right? Go to the instances. See, my private address starts with 172.31.82.4. So this is the range. Whenever I put any resources inside this, it will take one IP from here. Okay. If I go to the other machine, it will also be something similar. 172.31. The last two might is varying because it's a class B network. Okay, only the last two will keep on changing. 172.31 remains the same. So this is what your default VPC is. Okay, so default VPC, there will be a key here saying whether it is a default VPC, it will be given as yes. But you can create your own VPC and make it default by creating another VPC, making it default, and then you can delete this. Okay, you can do that also. So my suggestion is, at least for our course and session to be complete, please rename this one to some name where you don't have to delete it, and let's play around with creating our own VPCs, even though this one is still there, right? Because only now, while learning this VPC, we will be creating VPC and doing stuff, but other things now we'll be mostly using the default VPC because we don't want to go and do again the same thing and kind of waste our time, right? So we go back to the default VPC. So we talked about subnets. So there are 6 availability zones for Northern Virginia. So there are 6 subnets. So how are these subnets are broken? See here, they are broken as /20 network. So out of /16, that is 65,536, they have done like 4,096. They have broken that into 4,096 blocks, right? That is /20. /20. As I told you, it should be 496, but you get only 491 because I told you first 5, there are 5 IPs are reserved, so you will get only 4,091. Basically /20 will be 4,096. /20 means 2 to the power 12, which is 4,096. Now out of 91, already I have 3 machines here, so it has picked up 3 IPs there. So now this particular subnet US East 1C has 4088 because 3 IPs are gone for this one. If I now terminate this, all this will be returned back to this particular subnet. So these are all default subnets that they have. There are no names for it. We have only a subnet ID and the association where it is associated, right? To which VPC. That's okay. They're all public. They're all public. So everything is like public for you. See here, auto assign public IPv4 address is yes. So that means you will get all the public address and everything. They are public IPs. Go to a route table. Whenever you create any VPC, you get a route table by default. Okay, there's a default route table, and all the subnets are associated with this route table. That is why your internet or all your traffic, network traffic gets routed because of this route tables, right? And you have a default internet gateway already created for you. This is the name again I have given. So they will create internet gateway and attach to our default VPC. That is why you are able to get outside of your apartment and come inside, right, to the main gate, right? So egress only internet gateway is for your IPv6. We don't have IPv6, and this is what we have. Like, so we have endpoints, we have NAT gateways, peering connections. All these are empty unless you explicitly create them. Okay. So this, just think about this default VPC, because you may get some questions on your exams or in your interview regarding your default VPC. Okay. So you can have multiple VPC in a region, maximum 5 per region, soft limit I told you, and then maximum CIDR per VPC is 5. So you can have up to 5 VPCs. Once you create a CIDR, suppose for example I create a VPC. Okay, assume that I create a VPC called VPC A, and I assign this to that, right? 10.0.0.0/16. I have created now. I cannot go and edit this CIDR block again, but I can add additional CIDRs. I can add secondary CIDRs to it, like say for example 10.1.0.0.0/16. I can add this network. I can also add 10.16.0.0.0/16, another additional, like this. Up to 5 you can add. That's what it says, right? Up to 5 you can add, but once you have added, you cannot edit it. You can delete and recreate, but you cannot edit it. That is why you can do a maximum 5. You can add it as a subcategory. So as we talked about, minimum size is /28, 16 IP addresses, and maximum size is 16, which is 65,536 IP address you will get. Because VPC is private, only the private ranges are allowed. Only these ranges are allowed for your VPC: 10, 172, and 192. Your VPC CIDR should not overlap with your other network. So whenever you are designing your VPC, say you want to go for 10.0. something, make sure the existing corporate network or the network that you're talking to the third-party vendors or another company is trying to connect, all the network, you need to contact your network engineer, get the network profile of your company and understand the existing CIDR blocks that are being used, and you need to use the one which is not overlapping with that, right? As I told you, if it overlaps, a router will not know where to go and send the traffic to. Okay, so if you are designing a networking solution for your company, so the first question you need to ask the network engineer, give me the IP ranges that I can create which will not overlap with any of the existing networking. Then they will give you some range, and that is what you need to create. Okay. Any questions here, guys, before we get into the hands-on? There are a lot of things, but please go back to the recording also and make yourself like comfortable. Like when I say create a /16 network, you should know what is that /16 mean and how much IP and what will change. And if I say create a class A network, class B network, you should know what we are trying to do, right? That's the idea here. Let's go and see how we create our own custom VPC. So if you see this box, the one that I showed you on the top right, this is what we are going to do. So we are now going to start off with this one single box here. See the outside box? That's what we are going to start. Let's go and create a VPC and go and keep adding one by one. Okay, let's go and see. So what we are going to do, we are going to create a new VPC. Just go to your VPC and create a VPC. Okay, let's create only the VPC. VPC and more means you can also create a subnet along with this, but we will create all separately so you understand one by one, right? So let's give a name of this VPC. It's again optional. It's up to you whether you want. You can give a name, but let's go and give a name called custom VPC. Okay. Whether you want IPv manual input, whether you want input or IPAM allocated CIDR block. If you give this, you need to select from the pool, but we don't have any pool. You need to talk to AWS to get this pool. Okay. So let's go and give our own IP. Okay. I say my IP is like 10.1.0.0/16. So how will this IP will start now? If you see, when I give this IP, so 10.1.0.0/16. So by the first IP will be 10.0. It will be 0 to 255, then dot 0 to 255, which if you count it will be close to 65,536. Okay, this is the network range that I am creating. So I have created and I have bought the land with this particular square feet. Okay, now I'm going to break this and build houses or subnets within this /16. Within this 65,536 only I can do. Okay, I cannot go beyond that. Anyway, let's go and click this. Whether it's your IPv, you have an IPv6 CIDR block. No, we don't have any IPv6 CIDR block. If you enable this one, then you need to say, and it will ask you for which network group, which region you need, and then the Amazon will provide you the IPv6 CIDR block. And these are all public addresses which we cannot connect from our home because my device doesn't support IPv6. Okay, or at least our devices don't support IPv6 for now. So let's go for IPv4. Just come down and create a VPC. And this is your custom VPC. This is a custom VPC with this is a CIDR that we have created. Now, assume that I want to add additional CIDR to this, right? I need some additional CIDRs I want to add. Go say edit CIDRs. See here, you cannot remove or associate anything here, but you can add a new CIDR here. I want to add another new CIDR called 10.16.0.0/another 20 network, right? Something like this, or 16. You can go and add it here. After you add it here, you can remove your additional CIDRs, but not the primary one. Okay, just keep that in mind. So this is what I told you, up to 5 you can add it. Okay, this is one thing. Once you create your VPC, right? Once you create your VPC, select the VPC, go to actions and see, you can edit the CIDR block, you can edit the DHCP. These are all networking terms. We will be leaving all this default. If you are really interested, please go through this. This is nothing but your dynamic host control protocol. This is your DHCP. If you are making some changes, if you know what you are doing, please go ahead and do. Otherwise, just leave this alone because you will never be connected to this network then. Okay, so you should be careful in that. Now you can go and do a edit DNS hostname. So if I place any EC2 machine here, do I want a DNS name? In the default VPC, it will be enabled by default. So you need not worry. For the custom VPC, we have to go and enable this to get a host name. Otherwise, you will not get a host name. Save these changes, right? So that's it. Over. We got our VPC. So next, what are we going to do? We are going to create 2 subnets inside that 16/16. We are going to create 2 subnets. With 2 subnets, what we are going to do? We are going to make one as a public, another as a private one. Okay, let's go and see how to create a subnet and do this right in that. Go to subnet. Okay, there is already a default one. Don't touch anything that. Let's create a new subnet, and we have to select a VPC. For which VPC we want to create the subnet? We want to create it for the custom VPC that we created now, right? This is a CIDR block for subnet. What is the name of the subnet you want to give? Let me call it as public subnet, right? This is the name that you are giving. It's nothing that you need to give the same name, but just to indicate that it is a public subnet, I'll show you how and when it will become public, right? Availability zone. There are 6 availability zones, so you can create one subnet per availability zone or multiple also. I'm not selecting this, so we will keep this as kind of default, like let it go and take whatever it needs to take. Now here is the catch here. Now I have this 1000 square feet now. How am I going to break this, right? How am I going to break this? You can break in multiple ways you want. So you want to create /20 network, you can go up to 32 subnets if you have /20. So like that you can go. For that, I would like you to visit this URL when you have time. And I'll show you how to go and calculate this subnet, right? Fast. Understand this, and then you can use this tool. don't have to do manually. You have some sites to do this. So my address range that I have right now is this one, right? Take this guy and go and put it here. 10 dot, it's 10.1 or 10.16, 10.1, okay. 10.1.0.0 slash 16. See here, you can see here, the host address range is from 012 to 255 to 254, and this will be a subnet mask slash 16. Number of hosts you will get 65,536 if you're having one single network. So this is our VPC. Now I want to break the subnets, right? Suppose if I need only 2 subnets, what will happen when I do a 2 subnet? Then I can go for 217 networks, right? 217 networks. The first one starts with 10.1, second one starts with 10.1.128, right? It starts with like this. Now if I want to go for a 4 subnet, I want to break that 4. I want to build a 4 house. So this is how you can do as a slash 18 network, right? Keep on going like this, right? So then slash 19 network. See that it increases from 16, 17, 18 because we are going down now. So 16. So when I do a slash 20, I can go up to 16 subnets I can create. So I can have 8 now, 8 for the future, or whatever it is you can plan. See here, slash 20 network is 4096 IP. That is what the default VPC is also using it. Okay. So this is how you need to break your subnets and create. Okay, now I'm going for 20. How do I break this? This is my first IP address. So my first IP will be 10.1.0.0 slash 20. That should be my range for my first subnet. Let's go and see. 10.1.0.0 slash 20. This is my first subnet. Okay, let's go and create this as a public subnet. Okay, this is a public subnet I have created. If you go down here, you see here 4096 minus 5, 4091. Here you will get 4096 only. Okay, because this is a generic tool. It doesn't apply only to AWS. It is for the entire networking, right? So it's 4096. Let's go create another one, and we call it as private. Still, we haven't. I haven't shown you how it is termed as public, why it is termed as private, but we will go and create another this one also. And this time I'm calling this as a private subnet. Private subnet. So all this is fine. Now I have to put the second block. So I already, out of 1000 square feet, I already built our house for 200 square feet. I'm left with 800 square feet now. So I can go and plan accordingly. So I go for the next one. This is my next one. (16.0/20 network). So this particular range falls within our this one, so there is no issue. Scroll down and create a subnet. So we have created 2 subnets, one public and one private. Okay, just hit on this name, you will get both on the top. Okay, public and private subnet. See, public subnet, this is all the old subnet that was created 4 or 5 years before. So just 10 digit, now this is 17 digit ID, and this is attached to our custom VPC. These both are attached to custom VPC, and one starts with 10.1. So when I create a machine inside this subnet, the IP will start with 10.1. Then from here it will start with 10.1. After 16, right? 17, 18, 19, something will get. Go back, 4091. We did not specify any availability zone. By default, it created in 1E. Okay. Now, how do we say it's a public subnet? If you are able to connect to an internet, then it should be a public subnet. If you are not able to connect to the internet, then it is a private subnet. So when we define something as public, when I create an EC2 machine there, I have to get a public address. How do I get a public address, right? So select the subnet, go to actions and say edit subnet settings, and go and enable this. enable auto assign public IPv4 address. So whenever you enable this, any resources that is created EC2 will get an automatically a public address in this. So this will become a public subnet. Along with this, we also need to add the internet gateway to it, right? I've saved this now. This is a public and private. Okay, any questions here, guys? So far, we are going to launch a machine inside these things, and we are going to test it out by adding one by one component. So now, after we have learned about VPC, now we have to, when we are launching the machine, we need to make sure that we select our own EC2 and don't use the default one. So let's call it as public EC2. Go down. All this is fine. Very important. Come back to the select the key pair because you need to log in using key pair. Without that, you cannot log in. Go to network settings and do an edit. And here you need to select our VPC. Okay. And what is the subnet you wanted this to be? I want this to be in my public subnet, right? That's it. See here, we have already auto assigned public IP is enabled, but still you can go and override here also, right? You can override if you need. You can create a security group. Okay. Again, each and every security group is like VPC scoped. So the security group that I'm creating here will not be available in the other VPC. The security group I have in other VPCs will not be visible in this VPC. Okay. Just scroll down. Let's go launch this instance. Okay. Go and do a view all instances. Just refresh here. You will get your public EC2. Now select this. See here, you got a public IPv4 address. Now what we will do, we will copy this and go to our SSH and see if we are able to SSH to this, right? Go and do a git bash here and say SSH -i 0201.pem EC2-user at the rate of this public address that we got, right? This is what we normally used to do. Let's click on this. Nothing will happen. Nothing is happening. Why nothing is happening? Anyone? So we have a public subnet. We have a public IP. We have an EC2 machine. We have attached everything. Security group is open, but still you are not able to connect. Why?
SSH port.
SSH port is open, right? We have the security group open for SSH 0.0.0.0. So the reason is you don't have a main gate in your apartment. You haven't connected your internet gateway, right? So it doesn't know where to go, right? Where the traffic to go. So that's what we are going to add in the next row. So we just created the subnet, but we haven't written any route tables, nothing, right? Nothing has been written. So we saw these subnets. So as I told you, AWS reserves the 5 IP addresses, first 4 and last one in each subnet. That is why we are always -5. So these 5 IPs are not available for use and cannot be assigned to any instance. So if your CIDR block is 10.0.0./24, the reserved IPs are 0, 1, 2, 3, and the last one 255, right? So these 5 IPs. The first IP is reserved for your network address. The second is reserved by AWS for VPC router. They have their internal router. And second IP, the third IP is reserved by AWS for mapping to Amazon provided DNS server. And then the fourth IP is reserved by AWS for its future use, right? If they wanted some IP, because if they start allocating now, they cannot get back. So they are reserving one for the future. And the last one is the network broadcast address. AWS does not support any broadcast in VPC, but that is a networking broadcast. Always the last IP, 255 is the broadcast IP. Okay, this is how your network gets broadcasted to your IP gets broadcasted inside your network. So these 5 IPs will be gone. So that is why instead of 4096, we are always getting 4091 because of this. Okay, first 4, 0, 1, 2, 3, the last one 255. Keep this in mind. Therefore, the addresses are reserved. So in exam, you may get this right. If you need a 29 IP address for EC2 instance, you cannot choose a subnet size of 27. Even though you say 27, okay, 27 is 2 to the power 5, you get, but the problem here is you will get -5, right? Out of the IPs, 32 IPs, you'll get -5. You'll only get a 27 IP. So it's always better to go for the next bigger one, because everybody will miss this, because they will forget this 5 IPs. They will only go by the number, right? So always keep in mind, whatever the 2 to the power something you get the number, -5 is the IP in AWS, and it's available for us to use. Okay. So now let's talk about internet gateway. An internet gateway is horizontally scaled, redundant, and highly available VPC component that allows communication between instances inside your VPC and internet. Okay. So I have a VPC, I have an EC2, I'm not able to talk. So he's asking us to connect using the main gate, the internet gateway. Internet gateway serves two purposes: to provide a target in your route tables for internet routable traffic. So we need to have an entry in the route table also, right? To perform network address translation for instances that have been assigned with public IPv4 address. Internet gateways must be created and then attached to a VPC. And then we need to update in the route table and associate it with relevant subnets. There is no availability risk or bandwidth constraints because it automatically scales. If your subnet is associated with a route to the internet, then it is a public subnet. Very, very important, right? You sit for your interview, the interviewer will ask you, I have two subnets. Can you find out and let me know which is public and why it is public? Why it is public? Because that particular subnet is attached to an internet, so it is a public subnet. If it is not attached to an internet gateway and doesn't have a route entry to internet gateway, it is a private subnet. Okay, very important. You can attach only one internet gateway to one VPC at any point of time. So you can have only one main gate for your apartment. You cannot have multiple main gates. You may have some side gateways and all, but the main entry is only one, always, right? So it's the same thing here. So internet gateway is horizontally scaled, redundant, and highly available. It performs NAT between your private and public IPv4 address, right? So it goes from your subnet to, and it can perform a NAT. And it supports only IPv4 address. It doesn't support IPv6 address. So when you are deleting your VPC, your internet gateways must be detached before they can be deleted. You can attach only one internet gateway to a VPC at any point of time. Okay, let's go and see if we can attach the internet and still are we able to connect or not, right? So I have a main gateway. Go back to this one and go to internet gateway and create an internet gateway, and let's call this as my IGW, my internet gateway, right? My internet gateway, nothing else here, right? Create it here. Once you create it, it'll ask you to attach to a VPC. Either you can click on this or you come back and later also you can go attach to VPC. Both are same. Now, when the VPCs are listed, the VPCs which doesn't have any internet gateway alone will be listed here. See, the default VPC is not listed here because it already has a default internet gateway attached to it. So let's do this and attach this internet gateway. Fine. Now I have attached my internet gateway. Now what happens? Am I able to connect? Let's go and see. Still, I'm not able to connect because what happened? See, my internet gateway is there, but how will my traffic go to the internet gateway? I have to define somewhere, as in the route table, I have to create a route saying whenever the destination is internet, please go through internet gateway. I have to give that, only then the traffic will be routed from our subnet to outside. Okay. So let's talk about route tables. So I'm just taking you step by step. Okay. So please stop me if you don't understand anything, right? Routing, the VPC router performs routing between your availability zone within the region. So local routing is default, it will be there. When you create a route table, automatically a local route will be created. So that is why within the VPC you will be able to talk to any machine. The router connects different availability zones together and connects VPCs to the internet gateway. Each subnet has a route table the router uses to forward the traffic within the VPC. Route tables also have entries to external destination like internet. Up to 200 route tables you can create for a VPC. Up to 200 route tables per VPC. It's too huge. And each and every route table can have up to 50 route entries per route table. You can have 50 entries per table. So that means 50 into 200. Just think about that, that many entries you can have totally in a VPC. Each subnet can only be associated with one single route table. So one subnet can be attached only to one route table. You cannot have multiple route tables. So in your apartment, when the delivery boy comes in, the board that we have only one board, right? We don't have multiple boards. We have only one board stating for G1 go to Suresh, G2 go to Ganesh, right? That's what we say. Similarly, your subnet can only be associated with one route table. Okay. Routing, you can do routing. You can assign one route table to multiple subnets. You can have one route table assigned to multiple subnets, but at any point of time, only one subnet can have only one route table. If no route table is specified, a subnet will be assigned with main route table at the creation time. When you create a VPC, a default route table will be automatically created. That will be attached unless if you don't attach anything, it will take the default one. You cannot delete the main route table, but you can change that to secondary and then delete the main after you create another one, just like VPC. You can manually set another route table to become the main route table, and then you can delete the one that is already created for you. There is a default rule that allows all VPCs subnets to communicate with one another that cannot be deleted or modified. Routing between subnets is always possible because of the above rule. Okay. Any problems that you are having after doing all these things, it can either be some issue with your security group or knuckles, which we'll see later. That is called network access control list. Okay. Network access control list, and in AWS terms, we call it as knuckles. So when interviewer talks about knuckles, don't be surprised. It is just your network access control list. Okay. Now we have added this internet gateway. Fine. Now what is the next? Now next we need to make sure we add our route table here. See, we need to add a route table and add a route and see if we are able to route this traffic from here to outside the internet, right? Let's go and try that. So you have to work out this, otherwise it's going to be very difficult. Okay. See, there is a default route table that is created when we created this VPC, the custom one, right? We created this. Let's go create a route table called. This is for public subnet. I'm creating it as public RT, public route table, and I'm going to associate this with our custom VPC. That's all. Let's come down and create a route table. Okay. There are a couple of things you need to know for these route tables. Okay, these are all the routes. See here, there is a route, a default entry is there already saying when any network that the destination is 10.1.0016, which is that 65,536 IP, right? Please, the target is local. So you can communicate between different EC2 machines within a VPC using this route. And this route cannot be deleted. This route cannot be deleted. It is created by default. Okay, let's go and create a route so that we can connect to internet, right? So as I told you, this is a route table. You can have up to 200 route table, and each route table, this is a route table, private RT is a route table. This one entry is called one route, right? Like this, you can have up to 50 entries maximum. So what we are going to do, whenever my destination is internet, so how we represent internet, 0.0.0.0/0, all IPs, any IPs, right? Apart from this, any IPs, please go through my internet gateway. That's why you need to create the internet gateway and attach it prior to this. So now what we are saying, any traffic that goes to internet, please go through this guy. Please go through this guy, right? Save this guy. Now go back to the route. What you will see, we have created an internet gateway and we have attached to that internet gateway, right? Any doubt here, guys, so far? Now let's go back and still see whether we are able to connect or not. We are still not able to connect. Why we are not able to connect? See, we have created this internet gateway. We have created this. We have created this internet gateway and we have created a route table. We have an entry saying, right, hey, whenever the destination is 0.0.0, please go to internet gate, through internet gateway, go outside, right? All this is defined, but still I'm not able to connect. The reason for that is this particular route table doesn't know to which subnet it is associated. So unless you associate this route table with the appropriate subnet, the traffic from that subnet will not use that route table. Okay, so we need to associate our subnet to a route table, as I told you, right? So one subnet can have only one route table associated at any point of time. Let's go back and see there is a subnet association. The next tab is subnet association. When you click on this and say edit subnet association, there is nothing selected. So go on, we are now working under public subnet. Select the public subnet and save this association. Now what happens? We are saying whenever this route table is associated to this subnet, and whenever you are trying to access the internet, please use my internet gateway to go outside. Right now, let's see if we are still able to access or not. See here, we are able to access because all the things are done now. So this is how it is actually working in AWS. But so far that whatever we have created EC2 or used all the default VPC, default subnet, default route table, default routes entries and everything. That is why you were able to connect without even like looking at what is that. Now this is what actually happens in your VPC, and this is how it works. Now I'm able to get into my machine, right? Any doubt here, guys? So we are done here. Okay, so now this is public subnet. So when we any doubt here, guys, before we go to the next one?
No.
Okay, so we have created a public subnet, and we have also just created a private subnet, but we did not put any of our EC2 instance in the private subnet, right? So why we need private subnets and why we need public subnets? Suppose you are having a web application, the web tier is always on the public subnet because everyone, the outside users, need to access your application. And the private subnet, we will place all our databases, application servers, and all those tiers will be in private subnet. So what will happen if you are having a database? Say, for example, you have an EC2 machine and you have installed MySQL in the private subnet. So you need to constantly upgrade or update patches of those MySQL for in your EC2 that is installed from private subnet. So how do you connect to the internet? Right? You cannot connect because you don't have a public address for a private subnet. So you will not have a public IP. Then how you will connect it? That is where we talked about NAT, right? Network address translation. So let's go first create one machine inside private, and let's go and see what we can do, right? Let's try the same thing and see if we are able to do something. So let's go to, okay, let's go to route table. Before going to route table, let us go and create one private EC2. Now, if you see, we are here. If you try to ping Google, the same machine that we logged into, see, it is going to the internet. It is coming everything through your internet gateway and your route tables, right? So we are all good here at the public subnet. Don't worry about public subnet. We are all okay. Now let's go to private EC2. Let's create one private EC2. Scroll down. Okay, instance type. Make sure that you kind of have this. Otherwise, you will not be able to log in. Edit your network settings and select your custom VPC. And when you select your custom VPC, select the subnet. It's a private subnet. So auto assign public IP address is being disabled already. So you will not get a public IP. Okay. Let's go select an existing already that got created, right? So let's put this. Okay, all this is fine. Just go and launch this instance. So we have launched this in the private subnet. So we should not be getting any public address. Only the private address should be there. Okay. See here for the public address, since the subnet starts with 10.1.0.0/20, see here 658. Whereas if you go to the private now, You see there is no public IP and it starts with 16. So my IP is 17 dot something, right? So this is how we need to do. Fine. Now let's go follow the same thing and see if we are able to log into that machine. You cannot even log in from outside because there is no private IP. You cannot do anything, right? So what we will try to do, we will try to log in from private to public, and then we will try to see if we can reach the internet using the same method, right? And then we will see how to add our NAT and get it going, right? So for that, what we need to do, let's go and create our key file here. Let's go here and create our key file. Okay, copy this. Now, as I told you, within the VPC, you can connect to any machine because of the first rule, which says by default rule, the local targets, you can connect to any machine within the VPC, irrespective of the subnet. So that's what we are going to do and see if we are able to prove that, right? Is this, please be very careful when you are placing it, because okay, now try to do an SSH -i 0201 pep EC2 -user. See here, even though we logged in, it is 10.1.658, it's a private address. Now I'm going to use my private address to log in to this machine, private IP. This private IP, go here and okay, the key is protected, so you need to make sure sudo chmod 0600 or 400 0600 0201 pen. Okay, this is full open, so you will not have permission for this. Okay, see here, now I am from 10.1 from public, I am into the private now. Now if I try to do a ping Google, this guy should not allow me because it doesn't know where to go, how to go, right? Let's leave this open for now. Now let's go try to create another route table and see if we can do something, right? Let's go to the route table, create a route table, and this time we will call it as a private RT. Private RT, and select a VPC. Of course, this is for this VPC. Just come down. I'm creating a private route table. As soon as I create a private route table, I have an option to go on edit routes. And even if I say edit route, add route, I say go to the internet through my internet gateway. I have my internet gateway. Let me select that internet gateway. I save these changes. I come back to subnet association and I do a edit subnet association and I'll associate this route table to this one. I did the same thing, whatever we had, right? Nothing different. See, still the Google you cannot ping because you don't have a public IP address, so it cannot get into, and it cannot reach the internet gateway because internet gateway is in the attached to a public this one, so it cannot go there. So now next we need to talk about NAT, the one that we spoke about in the beginning, the how we use, that is what we are going to see, NAT. Okay, we will see the NAT and we will stop there and then we will continue tomorrow. Okay, so what we have here, all this is fine. Now there are two types of NAT that you can have. You can create a NAT instance or you can have a managed service called NAT gateway. We will be seeing only managed service. Nobody is using NAT instance, but you need to know the difference between NAT instance and NAT gateway. NAT instances are managed by you, that means by us, right? It's a normal EC2 instance which has the AMI, NAT enabled AMI, that's all. It's used to enable private subnet instance to access the internet. NAT instance must be created on a public subnet with a route to internet gateway. Okay, so you need to create this in a public subnet. Private instances in private subnets must have a route to the NAT instance with this destination. So what will happen? I send from my private to my router, I will send on the internet, then what will happen? The address will get translated to from private to public, go outside, get the details, come back and give it to my private machine. Very important, right? When creating NAT instances, always disable the source destination check on the instance. if this is one of the key questions that will come in the exam or an interview. If you are using a NAT instance, they give you everything, right? They say the internet gateway is there, everything is there, route is there, everything is there, but still you are not able to ping Google from your private instance. Why? If it is a NAT instance, you have to disable the source destination check on the instance. Let's see what is this, right? So take for example our house router, right? From my laptop, I'm just asking google.com, right? What's happening? It is going to my router, and router is taking the request outside the internet, getting me the Google page, and this source destination check is by default it is disabled in my router. That is why it is coming back to me, right? It is coming back to me. If I don't disable that, what will happen? The internet traffic will think that that is the destination, and your traffic will stop in the router itself. It will not come back to you. That is why you need to disable the source destination check on your the NAT instance. Okay. If you don't disable this, the traffic will stay in the NAT instance itself. It will not come back to your instance, your private instance. Okay. So you have to disable. By default, it will be enabled. You need to disable this. NAT instances must be in a single public subnet. NAT instances need to be assigned a security group because it's a normal instance. You need to make sure all the appropriate permissions are given. Security groups of NAT must follow the inbound from private subnet and outbound to all those things, right? Whatever we saw, inbound, outbound, it has to follow everything, right? So normally we don't use this NAT instances. The reason for not using this NAT instances, again, they are not highly available. They are not managed service. You need to patch your this one. Performance is dependent on your instance size. Okay, you can, if you need multiple NAT instances, you need to create multiple NAT instances in multiple subnets. And only advantage with NAT instances, you can use it as a bastion host. So think of bastion host as a jump server, right? Think of bastion host as a jump server. That means you can go to one server, from there you can connect to other machines. That's what you're saying as bastion host. NAT instances can be used as a jump server. You can monitor all the traffics, but this is not supported for IPv6. Only IPv4 is supported. We are not going to do this. If you want, you can try. I will show you how to create this NAT instance. This is what we do. So we have a security group. We have an EC2 machine, and this traffic will go here, and it will go to the NAT, and from NAT it will go out and get you. And if you disable the source destination check, this traffic will come here. It will not stay here. It will come out back here. If you don't disable, what will happen? This traffic will come and it will stay here. It will not come back down. That's why you need to disable the source destination check if you are using NAT instance. Okay. So, but we are going to use the NAT gateway. NAT gateways are managed for you by AWS. It's a fully managed AWS service that replaces your NAT instance on EC2. But it must be created in a public subnet. It uses an elastic IP for the public IP, so you will get charged something, so please be careful. Okay. Private instances in private subnet must have a route to a NAT instance. Usually the default route destination is 0.0.0/0. Okay. There's a small typo here. This should be gateway. NAT gateway. Okay, not NAT instance. Okay, NAT gateway, we should have the destination to the internet. It is created in a specified AC with redundancy in that zone. So when you create in one, even if something happens to that NAT gateway, it will automatically get triggered one because it is highly available within the availability zone. For multi-AZ redundancy, right? If you wanted to have multi-AZ, NAT gateways in each AZ with routes with private subnet to use local gateways. So you can create NAT gateway in multiple subnets. Up to 5 Gbps bandwidth it can support, and it can scale up to 45 Gbps. So which is that the transfer of data is very fast. So you cannot use NAT gateway to access VPC peering, VPN, direct connect, and other features you cannot use with the NAT gateway. So you need to make sure that you are including the correct specific routes to your route table. NAT gateways are highly available in each availability zone in which they are deployed. So even if that goes down, another one comes up automatically. You don't have to do anything. So they are preferred by our enterprises or corporations, right? Because you no need to patch. It's not associated with any security group. Automatically assigns a public IP address using elastic IP. You remember to update your route table and point towards your gateway. It's more secure. You cannot SSH into the NAT gateway. It's not a machine, so it cannot access a bastion host. You no need to disable any source destination checks. It is only egress only internet gateway operates on IPv6, whereas NAT gateways operate on IPv4. Only IPv4 is supported here. Port forwarding is not supported, so you cannot say you come through this port and send through that port. Nothing, because it's not an instance, right? Then using the NAT gateway as a bastion host server is not supported. You cannot SSH into this NAT gateway, right? This is what the difference is. You can go through availability. If you see, NAT gateway is managed by AWS and this is managed by you. Availability is highly available with him. It is not highly available. You will need to write some scripts and do this. Bandwidth up to 45 Gbps. This one depends upon the instance type that you select. If you have selected T2 micro, you will have only minimum bandwidth. If you need more, you need to select the bigger system and you need to pay more. Maintenance, this is managed by AWS. This is managed by you. So you need to patch. You need to make sure everything is up to date. Performance, they're optimized for NAT. Here again, it all depends upon your AMI that is configured with this instance, right? Public IP, elastic IP that cannot be detached. You cannot detach this. You can attach the elastic IP and detach it because it's a normal, easy to machine with NAT AMI. Security group, you cannot associate this with any security group. Here you can associate with security group because it again an instance, right? Bastion host, jump servers. Bastion host, they will never call jump server in the exam or an interview, and they are called as bastion host in your AWS. That is nothing but your jump server, okay? That is nothing but your jump server. So you will give an access only to one machine to log in first. From there you will go. You will get a Windows jump server or a Linux jump server, right? So that's nothing but bastion host. So don't get carried away by the term. Bastion is nothing but your jump server. NAT gateway is not supported. This can be used as a bastion host because it's a normal instance, right? So it's all same thing, only the logo will be changed from instance to NAT gateway. Now let's go back and see how we can see here. Still this is just hanging here. From private, I'm not able to access the internet. So now assume that from my home, I have wanted to access Google. So I have to go to the NAT, which is my router, and my router will go outside, get the Google and come back. That's what we are going to see. For that, click on NAT gateways first. Create a NAT gateway. Okay, and give a name of this name gateway. Again, this is also optional, right? So my NAT gateway. With subnet, it should be always NAT gateway should be inside the public subnet. See here, it can never be in a private subnet. It should be always in a public subnet. If it is in a private subnet, what will happen? The traffic will be within this subnet. It will not go outside the internet. So it has to be in the public subnet, so that the public subnet is already has a route to the internet. So it will use this route and go out and come back, right? So keep that in mind. So it's a public subnet. Connectivity type is public. I want to connect publicly. Elastic IP, I don't have any elastic IP right now. So let me allocate one elastic IP. It will automatically get allocated. Okay, that's it, over. Create your NAT gateway. Now I have created this NAT gateway, right? What should we do? We should associate this into our private route table. That's all, nothing else. Go to the routes, select your private route table, go to the routes, edit your routes, and now remove this guy and say add a route. Say whenever my destination is internet, please go through NAT gateway. That's all. NAT gateway, and save these changes. So what you are trying to say, if I want to go to the internet from here using this, you are saying whenever I want to go to internet, go to the NAT gateway, it will go to the NAT gateway. So NAT gateway knows that this particular subnet is already connected to an internet gateway. So that 0.0 will use this internet gateway, go outside, go to the internet and get back here. And since it's not a machine or something, this traffic will not stay here. This NAT knows from where this request came in, it will come and give it back to your machine. This is how your home router also works, and this is what we are seeing. Now just hold on for a minute. It will take some time. Once you are done with this, then you can go and see your route table, you have your route table associated with your NAT gateway. Go to the NAT gateway. It's still pending. Okay, just hold on for a minute. Once it is up, then you will see automatically your private machine is able to see here. Your private machine is able to ping your internet because of NAT gateway. So network address translation, that's what we talked about in our home. It's the same thing that is happening, right? But we don't configure anything. Everything is configured for you. But here, as a network engineer, AWS engineer, you need to configure, you need to know the concept, how this is happening, right? Now you are clear, right? So in the public, how it is able to do, in private, how it is able to do. Any questions here, guys? We will stop it here because it's too much, but at least if you have any queries, please let me know. So we have seen half of this picture. Go to the first picture, you will be able to see what we have seen now. We have seen this box, inside this box, right? We have seen all these things. Okay. Any questions you guys have? Please go through this video and try to do some hands-on. Otherwise, you will not be able to get this. Okay. It will all look easy when I am doing, because I've done this so many times. I know what I'm doing. But unless you go and try, it will be very difficult. So we went this step by step. We created one VPC. Then we created two subnets, public and private. And then we went and attached the internet gateway and we routed that. We created an EC2. We were able to get into that machine because it was in a public subnet. Then we created NAT gateway to access our internet from our private system, right? So now the public machine in the public EC2 that we have in a public subnet is nothing but your jump server, right? Because I logged into the server, from here I'm logging into private machine. So now my public EC2 machine is my bastion host. Okay, so this is what we will stop here. So let me know you guys have any questions, and you can see here we are in the private one.
Hi Chandra.
Yeah.
I just have the doubt on the IP address. How can, I mean, number starts and how we can start using them? Like 10, 1 are there? No.
See,
Initial
I
number,
told you,
so
right? Yeah, I told you, right? There are three ranges that are private. One that starts with 10, one that starts with 172, one that starts with 192. So these are all the
this is
three.
fine. The other public for public and all. Starting number. Sorry, I missed the first half an hour.
Yeah. So that's where I told you. You can go through the video. I've given you one tool. You can go and see here how many subnets you need. That will break up this whole segment into multiple subnets. Suppose you want to create 32 subnets, right? So this will be your range /21, and this is the first IP, this is the second IP, this is the third IP, start of the IP, right? This is the starting IP, 10.1.16.0, then 10.1.24.0. Like that, you can go on creating. How many subnets you need, that much you can create. We created 16 subnets, right? So that's why I went for a /20 network. So this is my first IP for first subnet, public subnet, and I kept it as this one for the second subnet, 10.1.16.0. It starts with 10.1.16.0.
Okay.
So go to the subnet. If you go to the subnet, we created one public, one private. See, the public subnet is 10.1.0.0/20. The second subnet range starts from 16. 0 to 15 is where the first 4096 IP will go.
Okay.
Okay. So that is how you see here. We have 89 and 90. Okay. So here there is a difference. Even though we created only one EC2, it should be 4090, but it is 4081. Why?
Sorry, I didn't get you.
No. Here, the public subnet. Okay. We have a two IPs gone. It should be 4091. Okay, two
first,
IPs gone.
those will be preserved for something, I think.
That is fine. That is 4096 minus 5. It is 4091. Okay. Out of the 4091, we have one EC2 machine, so it should be 4090 only, correct?
Yes.
But why it is 4089? Because we have a NAT. The NAT will also have a private address taken from there.
Okay.
Okay. That is why we have one more IP less. So this is the, you can go subnet your this one and you can take a look and try this out. Then you guys should be able to understand this. So we will now again revisit tomorrow our security group and talk about knuckles and security groups. What is the difference and what are the things that we are going to do? We'll go and talk about that. And we will be starting with other features like peering and stuff, endpoints and peering, right? So that is what we will go through. Any questions that you guys have?
Chandra, is still how many topics are left in AWS, Chandra?
We are going to go till 14 or 15. There are so many. There are so many.
Okay.
Up to this, right? Up to this and the next one that we are going to talk about is RDS. Both are bigger services. After that, everything is like we'll be able to complete one service in one class.
Okay.
So we will be done quickly. Don't worry.
Okay. I just
See,
wanted to know.
the thing is not like how quickly we do this, right?
Yeah,
How much
yeah.
answer
We
we
have to
do on this.
practice.
That is the main thing here,
Yes.
right?
Yeah.
So what you understand here, right?
Yes.
So because
True.
when you go and sit for your interview, the first question that will be asked by your interviewer is which service in AWS you are confident in. If they ask that question, right? If you are really confident in VPC or EC2 or S3 or whatever it is, say that alone. Don't just say all the services, right? Don't say I'm confident in all the service. Okay, that's a more generic term. They can ask you the service which you did not learn. So please be very careful when you answer your interview, right? Okay.
Okay.
All right, guys. Anything else before we stop for today? So we were able to connect. So this is what is happening whenever we did just create our EC2 in the last classes and all this happened default for us. So we did not know what was happening in the background, and now we clearly understand what type of network and what is the networking topology that we have in AWS and how this is actually happening. Right? Okay, fine. So once you are done with your this one, please make sure you kind of clean up your this one. Okay, let's do that cleanup also, right? Let's do the cleanup. Even though we have a class tomorrow to do, we will go and create one more tomorrow. So let's go and delete your private and public EC2 first. Go and do a terminate. So now you have a new logo here for terminate, a bigger warning here. Okay, this is because that UI team in AWS needs some work, so I think they would have given some work for them. Okay, let's go and shut down this. Once you shut down this, okay, let's go to the route table. Go to the route table. And one more thing, keep in mind, if you don't go and remove this route, the NAT route, right? What will happen if you go and delete the NAT? What will happen? Here you will get status as black hole. Black hole. That means wherever this goes, it doesn't know where to send, right? So because it doesn't have a NAT. So always try to please remove this NAT first before deleting the NAT. Edit this and remove this entry from the private one. Okay. Just wait for your instance to terminate. It is terminated. Now you go back and go to your VPC, select your VPC, and all the components that you created with the VPC will get deleted. Okay, let's go and see if we can delete that, right? Delete VPC. Please be careful. Don't delete the default one. See, wherever you are having red color, it will not be able to use that, right? And this ENI is still in use. Just hold on for a minute. It will take some time. And let's go down to our NAT gateway and go and delete this. Very important, not only deleting the NAT gateway. After you delete the NAT gateway, please make sure go to the Elastic IP, and please remove the elastic IP. You will get charged like a hell. Okay. You have requested for an elastic IP which was attached. See here. Now select this and just wait for this one. Then you will get a release enabled. Once it is get the release, please go ahead and release it. And sometimes it may get deleted along with the NAT gateway. If it is not, please go and do it manually. Otherwise, you will get charged. Okay. Just give me 2 minutes. We'll finish up this. Okay. I want to show you this cleanup, because if you don't do it correctly, you will end up paying $12, $15, $20 a month, right? So it's already deleted. Now go back here and do a refresh. Okay. And now go and see, you should be able to release this. Okay. Just hold on for a minute. This things will take some time. Now go back to your, it's NAT gateway is deleted. Now go back to your VPC and see if you can delete your VPC. Make sure you select the custom, and when you delete the VPC, again still your ENI is in use. Okay. Hold on. All these things will take some time. Once you're done, then please go ahead and delete this. Okay. You need to wait a little bit patient. And once you are patient enough, then just go ahead and try to delete that. And see here, once you are able to delete, you will get a delete button and you will get everything green. So all that we created by IGW, private, public, everything it will get deleted associated with those VPC. When you type delete without space, then you will get this delete enabled. Click on this. So it's deleting your VPC, internet gateway, subnets, route tables, routes, and everything. It will get deleted. Okay. Everything is gone. So go back to subnets. You will only see the default 6 subnets, nothing else, right? Go to the route table. You will only see the default route table that is associated with the default VPC. Okay. Go to internet gateway. You will see only one default internet gateway. You will not see the one that you created custom one. Okay. Go to elastic IPs and go and check if it is there. Go and release it. Very, very important, right? If you don't release it back, now my charge would have started, okay, unless I release it. Because as I told you in the last, when we talked about EC2, if you are creating an elastic IP, it has to be associated with some resource. Otherwise, it will get charged. So let's go release this IP. So here, this one is also gone. So we are now good. Go back to NAT gateway and make sure that is all deleted. That's it. Okay. So we have cleaned up both your EC2 and other things that you have created. Everything is cleaned up, right? Okay. All right. So one request from you guys, right? I don't know if you have already downloaded all the videos and materials that are there. I'm running out of space. So if you guys can go and download the entire folder by right-clicking the folder and say download, right-click this folder and say download. It will zip the entire folder and download it for you. I will go and upload this PPT and the recording for today. Please download the entire stuff. I will start deleting some of the older ones like EC2 and other things, right? I will start IAM and other things that whatever we had, I will go ahead and delete those videos. So please, I'll keep those other materials because they're all very small, but only the MP4 is taking up larger space for me. So it's becoming very difficult for me to upload new videos for you. Okay. So for today, I will go and upload and let you guys know. So please download it. It will just take 5 to 10 minutes depending upon your internet speed, not more than that. Download the entire stuff and please keep me posted in the WhatsApp so that I can go delete the stuff. Okay. All right. Any other questions that you guys have for today? We are done today. So please don't keep all these things that you will work at the end of this course or end of this AWS class. That will never happen. So please do it whenever you have some time, so you kind of remember, and I will be with you and you can get things clarified. After our classes are over, I will be still clarifying your doubts, but that will not be the same way as we are doing now, right? So this is the place where you can show your any issues, and we can troubleshoot, and we can kind of help you to navigate to the next level. Okay, fine. All right, guys. So thanks everyone. Have a good day. We will meet tomorrow at 7 a.m. and we will continue with our VPC's components. Okay.
Okay, Chandra, thank you.
Yeah. Thank you. Thanks everyone. Yeah. Thank you. Bye-bye.
Thank you, Chandra.
Yeah. Thanks, Chandra.
Yeah, thanks, Chandra.